My name is Tom Cramer from Stanford University, and you can probably still hear me. Thank you very much for having us. Because IIIF is a community-based framework, I will be one of many speakers today, and actually I will introduce very briefly the other speakers for today. Michael Keller, who may not be speaking but will wave, is the chairman of the IIIF Executive Committee and the University Librarian at Stanford University. I am Tom Cramer, Assistant University Librarian at Stanford University and the founder of IIIF. Sheila Rabun is the IIIF Community and Coordinations Officer. Stuart Snydman is my associate at Stanford University and manages the Mirador technical development for the Mirador project. Jack Reed is a software developer at Stanford University. And Mike Appleby is with the Yale Center for British Art and one of the IIIF specification editors. Each of us an expert in different facets of IIIF. When we speak about IIIF, what do we mean? And if we break down the definition, we're talking about international means global. Image relates to image-based resources, not just pictures, but any information resource that uses images as a primary information carrier. So books, images, manuscripts, newspapers, maps, musical scores, and more. By interoperable, we mean things that work together well, things that are simpatico, things that don't need extensive engineering or discussion in order to cooperate. And by framework, we mean multiple things that work together. A set of application programming interfaces, or APIs, software, a set of content that is exposed via these APIs, and perhaps most importantly, a community of people who are working together to advance interoperability. So, images, in addition to text, are one of the most important information carriers on the internet. They hold information on the web for everything from museum pieces to books, manuscripts, newspapers, maps, art, architecture, music. For most things that we work with in cultural heritage and research institutions, an image is a vital component. But image delivery on the internet is a challenge. It's technologically a challenge, and it's expensive and hard to do. Image delivery is, if you are providing information on the web, is hard. Image delivery is often slow. It is idiosyncratic from site to site or resource to resource. It is often disjointed. If you are working with images from multiple different sites, the experience and what you can do with images at different sites varies greatly. And perhaps most importantly or most tragically, image delivery is often an ugly and unpleasant experience for researchers and for end users. And we all suffer because of it. Institutions that are seeking to provide their content, image-based resources on the web, have to make it up in an individual way. Software providers have to write code for many different sites that varies from site to site, and users are forced to cope with these differences and unevenness. So the theory of IIIF is, what if there were a better way to deliver images? Here are some examples of how IIIF has already improved image delivery on the web in the last 5 years. Deep zoom with large images is something that most cultural heritage institutions have to deal with. In this image, this is a Japanese tax map from the 19th century and is quite extensive. We imaged this at Stanford University using more than 200 shots. The master file is more than 1 gigabyte large. How do you deliver this effectively to researchers on the web? And here you can see the actual physical dimensions of the map that we imaged. It is approximately 2 meters tall by 3 meters wide. That is our lead photographer at Stanford standing there, Wayne Vanderkill. He is about 2 meters tall in height. He's about this tall. So this image can now be delivered via the Stanford University catalog and the web via IIIF down to a mobile phone, and it just works. It's quite fast and an impressive experience. When researchers use information on the web, they often need to be able to cite and to share it. With images, that's typically to a file that's on the internet. With IIIF, you can cite and share images, including regions of interest. This is an example from the University College of Dublin, which is using IIIF to display a full image, identify a region of interest, in this case the drummer, and then through capturing just the coordinates produces a separate resource that is related to the original file but highlights the region of interest. This is an example of comparing images from the Wellcome Foundation, the Wellcome Trust. They deal with biomedical and life sciences information. In this case, these are computed tomography scans of the head of a seal. Using IIIF, you can bring up two images side by side and actually manipulate them, pan, zoom, and even invert the colors for finer detail and finer comparison. With IIIF, you can also compare images across multiple sites. Here is an example of Shakespeare-related portraiture from both Oxford and Stanford University. In this case, the image from Stanford is being dragged in real time into a comparison viewer called Mirador so that it can be viewed side by side with the image from Oxford. If you continue to look for other resources related to Shakespeare, the Yale Center for British Art has made all of their resources available by IIIF. And in the same environment, you can suddenly compare real-time images from 3 different institutions, again, with the ability to zoom, to pan, to annotate. The study in modern day also involves studying things that belong together logically and in some cases physically. In this example of a 16th century French manuscript, the miniature, the illustration has been removed from the surrounding page. These have been digitized and are held by 2 separate institutions in France. Using IIIF, members of the Biblissima project have actually brought this manuscript back together. They have virtually reconstructed it by bringing the images from the 2 separate sites and putting them into the same digital object. This is a live demo from the Biblissima project. IIIF makes all of these capabilities function now. The main theory behind IIIF is that information, the way we have traditionally treated information, is as silos, either information silos or technology silos, with very little ability to share content or applications across different providers. It is similar to this picture of grain silos, where content is isolated into its own silo, and to get access, there's a very thin catwalk across the top. Application programming interfaces, or APIs, enable reuse of content with multiple different types of technology. In this example, you might have a set of images that are available through a customized front end, but then also specialized annotation environments or search environments. And if every site uses the same APIs, one begins to see a fantastic ecosystem of both content and technology that is interoperable across the entire ecosystem. The vision for IIIF is to create a global framework where any image-based resource, image, a book, map, a scroll, etc., from any participating institution can be delivered in a standard way via any compatible image server to any compatible application on the web to any user globally. That's what we seek to create. With the demonstrations that you'll see from my colleagues in just a little bit, I think you'll see examples of this. As you step back and look at what IIIF might offer to those of us in the research community, I believe there are 2 things. First, IIIF dramatically reduces the friction of delivering image-based resources on the web. It's faster, easier, more performant, and with more software, you can publish your images once and be used across the entire ecosystem, and it supports attribution and access control. Beyond that, IIIF creates radical new capabilities to interact with images, to more than just view them. You can zoom, pan, interact, and manipulate the images. You can compare, reunite, and mash them up. You can cite, you can share, you can annotate, and in an exciting new development, you can begin to apply machine learning and artificial intelligence. And now my colleague Sheila Rabun will give more details about how IIIF works.
Hello, everyone. So I'm Sheila Rabun. I am the IIIF Community and Communications Officer. So what is IIIF? Our favorite definition is here. IIIF is a community that develops shared application programming interfaces, APIs, implements them in software, and exposes interoperable content. So first and foremost, IIIF is a community-driven framework. So we have participation from institutions and individuals across the globe. It's a global community, so this map gives you an idea of all the different areas from which institutions are participating with IIIF and using IIIF in their for their digital images. The shared APIs of IIIF, there are two core APIs. The image API, which allows for the transfer of image pixels and manipulating just the image pixels. And then the presentation API that provides more context and metadata around the image. You'll see a little bit more in depth about the APIs a bit later, but in general, this is the kind of thing that you can do with the image API. You can take a clipping of an image, make it bigger or smaller, change the rotation, and manipulate the color, all through URL syntax. And a quick overview of the presentation API. For each object that you're representing with IIIF, it will have a manifest. So for example, a book would have a sequence of pages. So the presentation API basically just provides structure and labels and descriptions and other contextual information about the object and images that you're showing. So when you put the two APIs together, you get something that looks like this with the image pixels in blue, and then, so that's coming from the image API, and then everything in red is coming from the presentation API, the title, the table of contents, and the image thumbnails. There are also a few additional APIs. One allows for searching within annotations, so the content search API. We also have an authentication API if you want to restrict access to certain images. And then we're also working on extending the presentation API to include support for audiovisual materials in addition to images. So with these APIs, our community implements these in different software. So various image servers and also image clients and viewers. This is just a sample of the different software that currently supports IIIF. And there are a lot more products that we're seeing supporting IIIF, and this is just a snapshot of some of them. And you saw some of the kinds of content that we're exposing through IIIF, but just a few more samples. Basically, the content is any kind of digital images. This image is just an example. It's a fun board game from Princeton University. But you can also make available images that contain text, so newspapers, manuscripts. We're also seeing more scientific type of images being made available through IIIF, and of course, all paintings, maps, manuscripts, photos, scrolls, sheet music, basically any type of image content that you want to make available on the web can be used with IIIF. So currently we have just about 400 million images on the web that are available through IIIF, coming from over 100 institutions. And Kyoto University Library is one of the many institutions that is making images available through IIIF. And so we have many adopters of IIIF, lots of applications and software that support IIIF, and many digital objects that we're making available. And so there's a lot of promise in this technology. So now my colleague, Stu Snydman, will talk a bit more about some IIIF software.
Good afternoon. My name is Stuart Snydman, the Associate Director for Digital Strategy at the Stanford University Libraries and the leader of the Mirador project. And I'd like to talk to you briefly about IIIF Viewers. As Sheila just showed you, the ecosystem of software for IIIF is vast and diverse. There are image servers, viewers, and more complex and sophisticated scholarly workspace applications. I will focus on two today, two of the more popular and well-adopted IIIF compatible viewers. The Universal Viewer, which has been adopted here at the University of Kyoto, and Mirador. Here is the popular tax map that my colleague Tom showed you earlier, shown in both the Universal Viewer and in Mirador. The Universal Viewer is called Universal because it can display many formats. It is capable of displaying simple images, books and manuscripts. It also has capabilities to display PDFs, audio, and video streaming from the web. Its book viewing capabilities are especially impressive, with the ability to navigate a book using thumbnails or other navigational controls, as well as view metadata and search within the book, allowing you to leap forward to search results zoomed in on the text that you found through your search. And while IIIF does not currently support 3D objects as part of the technical spec, the Universal Viewer has recently implemented support for rendering 3D models, some foreshadowing for what might be possible in the future for IIIF. The Universal Viewer has been adopted and is supported by scores of institutions from around the world and is being developed to evolve with the evolving IIIF specifications. Now I'll move on to Mirador. Mirador has three functions. Primarily, it is able to load content from institutions who are supporting IIIF around the world. It has the ability to view with deep zoom and pan, and it also has the ability to annotate content. But more than this, Mirador has become a very sophisticated scholarly workspace for comparison of content from around the world, annotation, and it has been used with many sophisticated use cases, from viewing and comparison to instructional and computational uses, as well as research and online exhibits. Mirador certainly excels at basic viewing of images, allowing the user to zoom deeply into the finest detail of color and texture. The major innovation of Mirador is the ability that distinguishes it from other viewers, is the ability to compare images in the same workspace. So you can see here the ability to open multiple images of celestial maps, the first two from Stanford University, and zoom and pan and compare the details. You'll also see the ability to create a more sophisticated grid layout, such as this 2x2 grid layout, and to add content from other institutions. We'll see the ability to find a celestial map from the Bodleian collection, at Oxford and drag the IIIF icon into the fourth window for comparison. Another important innovation of Mirador is the ability to annotate. Annotations can take any shape, and you can annotate regions on images with other images, text, audio, or video. Here is a rather sophisticated implementation of annotation offered by Harvard University for one of its cell biology courses, online courses. You can see when you hover over a region in the cell, descriptions of that part of the cell are displayed, and as you zoom more deeply, you can see annotations within other annotation regions. One of the more recently added capabilities of Mirador is the ability to display different layers of an image captured with different forms of photography. For example, this painting from the US National Gallery of Art was captured with traditional photography, X-ray, and infrared. The user can turn layers on and off, change their opacity to reveal important features. And I'm very happy to announce, with thanks to our friend, Dr. Kiyanori Nagasaki, the ability that the Mirador now supports the ability to support right-to-left reading order in its thumbnail navigation and paging navigation. There's also a desktop version of Mirador that you can download onto your local machine, so you can try all of its features and functions with images that are on your local computer. Of course, if you want to compare your local images to images supported by IIIF on the web, you need a network connection. But this is a great way to test and experience Mirador. Mirador is a global project with worldwide participation, adoption, and contribution. You can see some of the institutions that have contributed to the development of Mirador, including the University of Tokyo. All told, the equivalent of 16 years of effort has been invested in developing Mirador, and we continue working. Currently, we are in version 2 of Mirador and are now planning the next version, version 3, which will improve the user interface, redesign the technology architecture, and add new features for customizability and extension. We'll take the lessons of the past 8 years of work on Mirador to make a great new version. So, we welcome your participation and your involvement. I know many people in the room have used Mirador, may have ideas. We're very interested in hearing your feedback to contribute to the next versions. You can go to the project website, contribute on GitHub, download Mirador Desktop, or join our email list. Now, I'll ask my colleague, Jack Reed, to come talk about another important Mirador tool, IIIF tool and viewer, Leaflet-IIIF, and some sophisticated applications of IIIF.
My name is Jack Reed. I'm a software engineer at Stanford University, and today I'm going to talk to you about Leaflet-IIIF and IIIF integration into other types of applications. What is Leaflet-IIIF? Leaflet-IIIF is a JavaScript plugin for the interactive map library Leaflet. Leaflet-IIIF allows you to create performant interactive images using IIIF Image API. It is built on the popular JavaScript mapping library Leaflet.js. The Leaflet mapping library has become one of the most popular and widely used JavaScript mapping libraries. It is used by many companies and organizations worldwide. The library has also been adopted for uses outside of mapping, including high-resolution image viewing with IIIF. Leaflet-IIIF is a IIIF Image API client. Software that uses Leaflet-IIIF connects directly to the image using the IIIF Image API. Here is a basic example of using Leaflet-IIIF. A user is presented an image in which they can pan and zoom. This simple example is only a few lines of code. This example and all of the other examples I'm going to show you are linked at the bottom with source code. So what is so special about Leaflet? Leaflet is special because it was designed from the beginning with the core concepts of simplicity, performance, and usability. As a software engineer, these factors are important when choosing a software stack to work with. Not only are Leaflet's design principles important, but Leaflet has fostered a developer community and created a successful open source software project. Some of the key features that drives Leaflet's success are a high number of contributors, it's very lightweight, support for many browsers, excellent mobile support, accessibility, object-oriented programming principles, and no external dependencies. But the biggest advantage is it has a plugin architecture with over 400 plugins. These plugins can be used with Leaflet and Leaflet-IIIF applications. Here is a great use case of IIIF and Leaflet working together with plugins. Digital Typhoon provides users the ability to select a clipping from the Himawari 8 satellite photos. This application integrates Leaflet Full Screen and Leaflet Draw plugins within the IIIF curation viewer. Users can zoom into an area of the Earth, create a selection using the mouse, and then export or save that selection. Because Leaflet-IIIF is built on top of the mapping library Leaflet, layering images and content is very easy. Here is an example of a folio from a manuscript with a missing graphic. The cutting is held in another library and can be added in an overlay. This is another example of adding a cropper to an image. Notice how the URL at the top of the image is updated as the user pans and zooms the image. This URL of the new cropped image can be used in other applications. So this is an example of an application we have called Spotlight, and Spotlight uses IIIF cropped images in the header and in these representative thumbnail images. Leaflet-IIIF has been integrated into many applications for viewing IIIF images. It's being used in the Europeana search application, as well as Polyano, an annotation application from the United Kingdom. Leaflet-IIIF has seen widespread adoption in North America, Europe, and Asia. It's often a great choice when developing IIIF image applications. IIIF content is ripe to develop machine learning and computer vision applications. Because IIIF is native on the web, it can provide a consistent way to access images for doing computation. IIIF speaks annotations out of the box, so it's also really useful for classification and shape detection. And it provides interoperability for image processing collaboration across researchers. HistoNets is an application designed to turn historic road maps into vector data used for research. It uses a combination of machine learning and computer vision techniques to assist users in automating graph vector data creation from images. Before this application was developed, researchers would painstakingly create this data by hand. This was prone to many mistakes and took a very long time. The entire application is backed by IIIF. This allows developers internally to use common APIs for consuming and sharing images. And here is a demonstration of the HistoNets process. A user can select images to crop, then the machine learning assisted image cleaning process is used to pre-process all of the images. Next, a user can select areas that are used for templates or nodes of the graph, intersections. Finally, computer vision will go and select similar nodes in all of the images. This is just a part of the pipeline, but I wanted to share it with you to see how IIIF can be used within an application successfully. We can also share the same content. So here are the matches found in the HistoNets application, and it's being imported into Mirador for review. And there have been many other machine learning integrations with IIIF content. Here is an example provided by CogApp. They have used the Google Cloud Vision API, Microsoft Computer Vision, and Clarify to automatically classify 2,000 images from the National Museum in Sweden. Here we can see on the left-hand side all of the image classification tags that were created automatically.
Hi, my name is Mike Appleby. I'm from the Yale Center for British Art at Yale University, and I'm going to talk a little bit about the IIIF APIs and give you some demonstrations that hopefully relate the APIs to what you've seen already, with a couple of new demos thrown in. Sheila showed this slide earlier with the image API, and it gives you an example of how the image API allows a software client to request an image or a region of an image. In the example shown here, a request is made for a specific region of interest, in other words, the face, and then the rest of the URL defines how that image should be scaled, flipped, rotated, and changed to grayscale. And then finally, the .jpg extension indicates that that image should be returned by the server to the software client as a JPEG. So some interesting applications are can be constructed using just the image API. And I'll give an example here of a small program developed by the Victoria and Albert Museum. The Victoria and Albert Museum has a sketch shown on the right of an oil painting that is held at the Yale Center for British Art. And we also, at the Yale Center for British Art, have an oil painting that is a sketch or a precursor to the final painting. And so the Victoria and Albert Museum has developed software that pulls the images from both Yale and the V&A and allows them to be brought into one tool, which then allows the images to be overlaid and cross-faded, and then the user can align the images, scale them, and adjust the alignment in order to overlay them or register them. And the goal of this is to show the difference in the composition as it changes over time from the sketch to the next sketch to the final painting, and you can see the differences kind of more clearly as they are as they're overlaid. And they use this application then to drive a rendering online on their site, which again draws the images live and requests the overlaid images in the correct dimension and the correct region. I'll talk a little bit next about the presentation API. The objective of the presentation API is to provide the information necessary to allow a rich viewing experience in a software client, likely in conjunction with the IIIF image API. The core or central object really in the presentation API is the manifest. And the manifest contains the data necessary to represent an object. It contains the structure, the sequence of images and so forth, and also metadata that's intended to be displayed to the user. So not structured metadata, but display metadata. Another central concept of the presentation API is that of the canvas. The canvas is a blank canvas or a blank area, and the images to be displayed in that view, or in that particular canvas, are associated with it via annotation. In the presentation API 2, we use the open annotation specification. In the coming version of the presentation API, we will use a W3C web annotations, which is a W3C standard. Each manifest that represents the object contains one or more sequences of these canvases, and each of those sequences gives you the sort of page order view that you would see sort of at the bottom of the screen, or if you look in Mirador across the bottom, or in Universal Viewer down the side of the screen. The presentation API also contains many other properties that can be used to provide a label, description, thumbnail, technical information, including the viewing direction, and links to external files or external websites. So a link to your online catalog or a link to a metadata file. Work is currently underway on presentation API 3, and this will include support for audio and video. So in addition to having an X and Y axis, each canvas will have a timeline that will allow annotations to appear at different points in time. Now let me talk about one of the examples we've seen, which is the reunification of this manuscript that has had the miniature cut out. What does that look like in terms of the API? Well, we have a canvas, and the image of the page is annotated onto the entire canvas, and the image of the fragment, or the miniature, is annotated at the appropriate X and Y coordinate to fit the gap, and the height and the width are specified correctly so that that image is scaled to fit in the hole in the page. And the result is this demonstration that you've already seen twice, which is that the miniature can be turned on, and it will load separately into that space defined by those coordinates. Another approach is to use multiple images that target the entire canvas. This lets you build a sort of a stack of multiple images that can be turned on and off. So similar to the example that you saw earlier from the National Gallery of Art, the woman in the red hat, here's an example from the Yale Center for British Art, where we have an X-ray version of the painting, and we can turn on a overlay that is a conventional photography, and we can adjust the opacity of that, so you can then start to see some differences between the X-ray version and the visible light. And if we zoom in and adjust the opacity again, you'll see around the head that there is a hat or a bonnet that's visible in the X-ray, but it's not there. It's been overpainted, and it's not visible in the conventional photography. And now a final example is just to show you the power of the deep zoom. We have a canvas. The underlying image is about 6,000 pixels across, but we can annotate a very high resolution image into a very small area on the painting or on the canvas. So we can annotate a 5,000 pixel image into a very small area. And viewers like Mirador will allow you to zoom in completely on those detail images. So again, here's another painting. We have many detail images as well as some UV and IR. And we can just turn on the various detail images, and they are overlaid. See that, and then we can zoom in to a very deep zoom in to the full resolution of that small of the image that was annotated onto a very small area. So it's a very powerful capability for overlaying these types of images. And as you can see here, again, as with the X-ray, if you have multispectral imaging or other types of imaging, the ability to crossfade can allow you to detect changes that you might be interested in. And with that, I think I'll thank you very much, and I'll hand it over to my colleague, Sheila Rabun.
So that was an intro to IIIF, and I'm going to just speak a bit about how to get involved with IIIF and the community. First, there are many ways to participate. If you are making digital images available online, the best way to participate is to make sure that your images are IIIF compatible and use the software that supports the IIIF functionality. We also have a number of communication channels that I'll show in just a minute, but we now have a Japan channel on our Slack team. And so these are the different communication outlets that we have available, including our website. We have an email list, the IIIF Discuss at googlegroups.com is our email list. The Slack team that I mentioned, you can join at this bit.ly link there, and when you join, you'll see that there is a specific channel for Japan, so you can find out what others are doing and share information there. We're also on Twitter. We're at IIIF_IO, and we use the IIIF hashtag. And there are some other resources on GitHub and on YouTube that we have available. We also have a number of events like this one, so thank you for coming to this event to get involved. And then I also have my email address here to get in contact. This slide just shows our email list, and our Slack group have grown over the past years, and we're hoping to see more participation coming in the future. And this is the Japan channel in our Slack team that I mentioned. So to stay involved and keep up to date with what's going on in the IIIF community, this would be a great place to start. And then we do have a community newsletter on our website, and this is a great place to go to see what's going on with the community. And a new newsletter will go out in November, and that will have highlights from this event as well. And the next big IIIF event that we have coming up will be in May in 2018 in Washington, D.C. And this will be our IIIF conference. We have a conference every year. Last year it was in Rome in the Vatican, and we had several participants from Japanese institutions, and we hope to see many more at our next event. And we're very excited because it's going to be hosted by the Library of Congress, the Smithsonian Institution, and the Folger Shakespeare Library. So it's a very exciting event for us. And finally, we have a consortium of 47 institutions across the globe that make up the IIIF consortium. You can learn more about it online, but this is a group that provides sustainability and steering for this initiative. And we are looking for more institutional members to join the consortium. We have an impressive list of prominent cultural heritage institutions across the globe, including Kyoto University Library Network and also University of Tokyo in Japan. And we would love to have even more institutions join the consortium. So please consider that as well. And that concludes our keynote. So thank you very much. And I'm looking forward to the next presentations.